In this problem, we're being asked to determine the convergence or divergence of the given series according to the divergence test of the nth term test. Now, what we would want to go ahead and do here is take the limit as n goes to infinity of our general term, so 3 to the n cubed plus 1 all over 5n cubed minus 2n squared plus 1. To determine what this limit is, one way we could do this is keep in mind that for rational functions, we would just look at the leading terms. So in our case, the leading term in the numerator is 3n cubed. The leading term in the denominator is 5n cubed. So this limit is actually equivalent to the limit as n goes to infinity of just 3n cubed over 5n cubed, which is also equivalent to the limit of 3 over 5, which we know is just 3 over 5 because there is no n in this expression, right? There's no n in this term. So the limit disappears, we just get 3 over 5. So I know that the limit is 3 over 5, which is certainly not 0. We could then go ahead right away and make our claim. If we wanted to do this a bit more algebraically, what we could do is from here, we would go ahead and take our limit and we would divide every single term by the highest power variable. In this case, we're going to call n our variable here. We're going to divide every single term by that highest power. So in our case, we're going to divide everything by n cubed because n cubed is the highest that we have in the entire rational function, okay? So if I were to divide every single term by n cubed, n cubed, n cubed, and so on and so forth, what would we get? Well, 3n cubed over 3n cubed would be 3. 1 over n cubed is 1 over n cubed. 5n cubed over n cubed would be 5. 2n squared over n cubed would be 2 over n with the negative there, and then 1 over n cubed stays as is. So now when you do this, think about the limit. Limit doesn't affect the 3 and the 5, of course. In these terms here, here, and here, when we go to infinity, the denominator grows faster than the numerator. These are all going to push towards 0, right? So in all of these cases, these are pushing towards 0 because the denominator is going to grow faster than the numerator according to these growth rates. And our limit is just left with, same as what we had up above, 3 over 5, okay? So now, since again, this is not equal to 0, we would go ahead and make our claim that our original series, n equals 1 to infinity of, let's do a rewrite here, 3n cubed plus 1 over 5n cubed minus 2n squared plus 1, diverges according to the divergence test or the nth term test, right? However we're calling this in your class, that would be our statement there.